Hi guys, today we're going to be looking at similar triangles some more. Remember yesterday we learned that two triangles are similar if all of their corresponding angles are congruent. And then if you have similar triangles, you can use the idea of proportional relationships to find some missing measurements. So let's take a look at what we got. So here in the diagram below, CB is parallel to DE. Are the triangles similar? Explain. So we need to find some missing angle measures and make sure those two triangles are similar to each other. So we have here a diagram with some vertical angles, and we remember that vertical angles are congruent. So since this is 20 degrees, this is also 20 degrees. Okay, so now we can take a look at the two triangles separately. If this triangle here, this larger one, has 20 and 84, we can find this missing angle. So we can do 20 plus 84 is 104, and then 180 minus 104 is 76. So that means this missing angle right here is 76 degrees, which happens to be the same as B over here. So that means that C has to be the same as E. So this is going to be 84 degrees. I can prove that to you. If I do 76 plus 20, I get 96. And if I do 180 minus 96, sure enough, I get 84. So now we know, or have proven, that those two triangles are indeed similar. Yes, they are similar because all corresponding angles are congruent. Okay, so then part B, write and solve an equation to determine the lengths of sides given as algebraic expressions. So when it says write an equation, a proportion is an equation. So we're going to write a proportion. Anything with x in it that you're solving for is an equation. So again, we have to keep in mind these corresponding lengths. So this 76 to 20 makes a corresponding length with this 20 to 76. So 9 and x are going to be similar. So if we go from 9 to x, we're going from bigger triangle to smaller triangle. And now we want to find another corresponding side. So we can think about this 12 and the 8, which makes sense because that's 84 to 20 and 84 to 20. So we're going to go, again, bigger to smaller, 12 over 8. All right, so now I've set up my proportion. I can cross multiply and solve. X times 12 makes 12x, and 9 times 8 makes 72. Divide by 12, divide by 12, and x equals 6. So the missing side length here is 6. Okay, and that makes sense because if you do 12 divided by 8, we get 1.5. That means our scale factor is 1.5. So if I do 9 divided by 1.5, I do get 6. So it's another way of doing the math. And if you were to show that work, you could get partial credit, but because you're not solving an equation, you're not solving a proportion, but you are getting the correct answer. All right, let's continue. Number 2, given the triangles below, answer the questions that follow. First, are the triangles similar? So again, we got to find some missing angles to make sure they definitely are similar. We know they both have 90-degree angles because these two have those little boxes in the corner. This one up here is 56 and this one down here is 34. So let's see if those other angles are going to match up. So if we do 90 plus 56, we get 146. And if we do 180 minus 146, sure enough, we get 34. So we've proven that these two triangles are similar. This would have to be 56 because of the math. Again, I could prove it to you. If I do 90 plus 34, I get 124. And then if I do 180 minus 124, I indeed get 56 degrees. So yes, they are similar. Because the corresponding angles are congruent. Then write and solve an equation to determine the lengths of the sides given as algebraic expressions. So again, we're going to set up a proportion. All right, so we want to go from one triangle to the next and be consistent with how we're setting that up. So if we go from left to right, 15 is going to be similar to 16. Then back to left, 4x minus 2 is going to be similar to 4x. So now we cross multiply. And 16 times 4x minus 2, if you multiply across, is 64x minus 32. And 15 times 4 is 60. So we now have an equation with variables on both sides, which is something we've learned to do in the past. We want to even out our equation by bringing the variable to the opposite side. So we subtract 64x from both sides to balance, and we bring down what's left. We've got negative 32 equals negative 4x, and then we divide by negative 4, giving us x equals 8. But in this case, that isn't the length of the missing side, it's just part of it, so we have to plug it in and find the actual missing sides. So we do 4 times 8, which is 32, minus 2, so this side is going to be 30. And then over here, we know that 4 times 8 is 32. So 30 and 32 are our missing sides, which makes sense that 15 to 16, 15 times 2 is 30 and 16 times 2 is 32. So those triangles are proportional to one another. All right, so that's a lot of work needed for what looks like a little question, but make sure you're taking your time and working through it, showing your equation and all the steps necessary. So number 4, you're going to try on your own, and then I will come back and help you out with some of the others. Oh, I missed number 3. So let's go back to number 3. You're going to go and do 4 on your own eventually, but let's go back to number 3. All right, so now in number 3, it's an even trickier problem because the triangle is within a larger triangle. So we have to kind of break them apart. So first part is triangle ABE, similar to triangle ACD, and we're going to explain that. So here is triangle ABE. It's a smaller triangle right here. And we have that 28 degrees and the 90 degrees. Then triangle ACD is the larger triangle around it. So that's all the way through here, here, and here. So they share that 28-degree angle, and they both have a 90-degree angle. So that should be our proof that they're definitely similar because 2 of the 3 are definitely congruent to each other. But let's just find the third. So if we do 90 plus 28, we get 9, 10, 11, 118, and then 180 minus 118 is 62 degrees. So that means this is going to be 62 and this is going to be 62. So the triangles are similar. Once again, because all of the corresponding angles are congruent. Hopefully you've got that sentence memorized by now. Okay, so then part B, write and solve an equation to determine the lengths of the sides given as algebraic expressions. So again, we're setting this up. Let's think bigger or smaller to bigger. So if we look at the smaller triangle, this 5 inches has to be proportional to the 10 inches, which gives away the scale factor. But because we have algebraic expressions, we can't just go right in and get those answers. So 5 is to 10 as 3x is to 3x and 12. So that's 3x plus 12. Okay, putting those two sides together. So now we cross multiply, and 10 times 3x is 30x. And then we cross multiply again, and 5 times 3x plus 12, we distribute the 5 equals 15x plus 60. Plus 60. We subtract 15x from both sides, and we get 15x equals 60. Divide by 15, and x equals 4. All right, so now we figured out what x is equal to. So AE is 3x, which is going to be 3 times 4, which is 12. And that can be written as inches because it says it in the diagram. And then AD, we know, is 3x plus 12. So that's 3 times 4 plus 12. So that's 12 plus 12. So it's 24 inches, which makes sense. If the first one has a height of 5 times 2, that makes 10. So if the bottom one, the smaller one, has a base of 12 times 2, that would be 24. So they are in proportion to one another. All right, so now you are going to be on your own with number 4. Take your time, go through it slowly, make sure you're showing all that work and answering the questions completely.